My name is Ludwik Trammer, and I'm a senior software developer / machine learning engineer at deepsense.ai.
And I'm Dawid, Żywczak, front-end engineer here at deepsense.ai.
And today we will be talking about Google Flutter. Both me and David work recently at building AI mobile applications at deepsense.ai with Flutter. So partially this presentation will be a chance for us to share our experience. First, I will describe what is Flutter, and then David will show you how to use Flutter and why you might want to use Flutter. So, what is Flutter? According to the official website, Flutter is an open source framework by Google for building beautiful, natively compiled, multi-platform applications from a single code base. There is a lot of parts in this single sentence, and I will try to explain each one later. But for now, Flutter basically is a framework from Google for building applications. And actually, the idea first came up in the Google Chrome team as a thought experiment. As you probably know, nowadays, web browsers are the main platform for running applications as web applications became very popular. But the web wasn't originally built for applications, and some people at the Chrome team became maybe a little tired of having to support this modern use case. And they started to wonder, how would an application platform look like if they could just start over and build it from the ground up? And that's how they came up with the first principles of what would later become Flutter. And of course, later Flutter became its own big project and big team inside of Google. So, what's so special about Flutter? First of all, it is multi-platform. The official tagline is build apps for any screen. So you can use Flutter to build mobile applications for Android, for iOS, and there is plenty of mobile applications built with Flutter, both from Google and from other companies. You can use Flutter to build desktop applications for Windows, macOS, Linux. For example, the official Ubuntu Linux installer is built in Flutter, and most recent Ubuntu applications are built with Flutter. You can use Flutter to build web applications, content-heavy websites, not so much, but applications, certainly. And you can quite easily add support for other custom devices. For example, Toyota uses Flutter for the screens inside their cars. And importantly, you can build for all those platforms from a single code base. So you don't have to have a separate version of your code for every platform. You can write the code once and then compile the code for iOS or for Android or for Windows or Toyota cars. But importantly, you still have access to features of those individual platforms. For example, camera or GPS for mobile phones. And you can access those features either using Flutter plugins, which gives you an interface that is unified between platforms, or when needed, which is pretty rarely, you can access the underlying APIs of a given platform directly. What else? Flutter is fast. The code is fully compiled to native machine code for each platform. This is quite different from how most multi-platform frameworks work. They are usually based on JavaScript, and the JavaScript is interpreted in the runtime. This is very different from how Flutter works, which fully compile all the codes to native machine code, which is of course quite fast. The other major optimization is connected to the rendering process, and actually it is one of the principles that came up during the original thought experiment. Flutter guarantees that during the rendering process there will be a single pass of the layout algorithm, which is very different from how the rendering works for the web, where you can have dozens of hundreds of iterations of the layout algorithm as different elements change their size based on the size of other elements, which change their size based on the size of yet another elements, and so on and so on. Flutter was able to sidestep the whole problem from the very beginning, which makes the rendering very fast. What else? Flutter is productive for the developers. For example, it supports hot reloading, which means that even though the applications are compiled, when you change something in the code as a developer, you see the change immediately reflected on the screen. So you change something and almost the same instance, you see the change reflected in the app, and you can even test the change without having to wait for the application to recompile. It's a little bit like magic, and you will see this in a minute in a demo from Dawid. Also, as a developer, you have pixel level control. Since Flutter draws its own screens without delegating this to system components, you can control precisely every single pixel that's drawn on the screen, which leads to accurate designs and accurate animations. But of course, usually you don't work on the level of individual pixels. In Flutter, you work with widgets, and almost everything in Flutter is a widget. So you declare how the screens of your application should look like by composing them of widgets, which can have other widgets nested inside of them, and so on. And you do this using a programming language, the same language you use to build the rest of your application. So there is no separate UI markup language like XML. And honestly, at first, this seemed a little weird to me. But after using it, I came to really like this, because this means that you can use the usual programming patterns, conventions, tools, the flexibility of programming languages to build your interfaces. And the programming language that you use with Flutter is called Dart. Frankly, it is quite similar to JavaScript, but it is compiled, it is typed, it supports modern features like null safety, and it doesn't include all the weird behaviors that are in JavaScript because of the historical and compatibility reasons. I should also tell you that Flutter comes with libraries of built-in widgets that are designed to look and behave like the native system widgets. So you can use those or customize them or build your own widgets. And actually, you will see this now in a demo from Dawid, who will show you how to create your screens with those widgets. David?
Okay, so moving to the demo, let me show you the code. I think that should be visible now. So we know what Flutter is. So let's see how it works. Here we have some simple application which I called Puppy Magic, just like image magic, but we are going to manipulate images of some puppies. So that's it. It allows users to select an image of a dog from their gallery and recreate this image in one of the available styles using OpenAI's API. For the purpose of the demo, I have pre-generated a set of images for 3 dogs so that we don't have to wait for the requests to complete. At the top, there is an app bar with a title. Under that, we can see a placeholder for a selected image. Moving on, there are some buttons for selection, drop down, and a button that triggers the generation. It may not be the most beautiful and user-friendly interface, but the main purpose of this demo is to show you the basic workflow of creating a front end using Flutter. So let's take a sneak peek at the code. As you can see, I have one widget called home screen, which is a stateful widget. That allows it to hold some state and tells Flutter to render when that state changes, just like the useState hook in React. Under that, we have a home screen state class, which at the top has 4 state variables defined. And then there is a build method, which should return the widget tree representing our interface, which means some containers, texts, images, etc. Flutter calls this method every time the state changes. I won't go through the existing code step by step, but let's add some functionalities to it. As a user, I would like to clear my selection and reset the application to the initial state. I can do that by closing it completely, but using a button would be much easier. So let's locate the pick an image button, which comes from the gallery picker widget that I created before. There it is. As you can see, it's wrapped within a row container, which allows widgets to be displayed side by side. First, let's add some sized box with a set width of 16 pixels, which will add some space between our buttons. Then let's add a text button, which takes on pressed parameter, and some child, which will be the label. And let's save. As you can see, the pick an image button moved to the left a little bit, but nothing appeared yet. So let's add the real label for the button, which would be clear selection. So, and as you can see, it appeared. But it doesn't do anything right now because we have an empty callback passed to the unpressed parameter. What we are going to do is first, we are going to check if generated or maybe selected image is not null. And in that case, we are going to pass real callback, which would use a magical set state method, which tells Flutter that the state changed and the widget needs to be re-rendered. Here, we will clear the generated image and the selected image by setting them to null. In the other case, we will pass null as a handler, which should disable our button. And let's test it. And there we go. We cleared the selection and the generated image, and button is now disabled. Let me pick an image again, style it. And as you can see, there is no loading indicator when users are waiting for the results. So let's add some spinner with an overlay. First, let's start by locating the part that displays the generated image. It should be at the very bottom, and there it is. As you can see, it's a container with some fixed width and height. Let's start by wrapping it with stack, which allows widgets to be displayed on top of each other. It takes children array as a parameter. Then let's wrap that stack with another container and move the sizing here so that the whole stack is 200 by 200 pixels. Then we are going to also move the decoration of that container and to be exact, the border radius, which will add some circular corners. And as you can see, we have some overflow of the content. We can fix that by using clip behavior and setting it to clip anti-alias, for example. We also need to move that condition here so that so we only hide the generated image, not the whole stack. Now that we have wrote that piece of the code, let's utilize the stack by adding a centered spinner using center widget and circular progress indicator. And there we go, we have a spinner on an image. The spinner isn't clearly visible when there is an image under it. So let's fix it by adding some overlay. We can achieve that by wrapping that center widget with a container and setting a color. First, let's check if the generated image is null. If so, we are going to use transparent color so that we don't display overlay on the white background. Otherwise, we are going to use gray color with some opacity of 0.5. Save that. And as you can see, we have a nice overlay. But there is one issue left. The spinner is always visible, even though there are no pending requests. Let's fix it with some style by adding a basic animation. We are going to do that by wrapping this container with animated opacity widget, which allows us to animate between one opacity and another with some duration set by us. So let's set opacity parameter. When we are loading something, the opacity should be 1 so that the spinner is visible. Otherwise, it should be 0. And let's set the duration of the animation to 300 milliseconds. And there we go, the spinner disappeared. Let's try to generate another styled image. It appeared, it looks beautiful. Let's also test it on the white background. And there we go, there is no overlay. Everything seems to work fine. And that would mark the end of the demo part. And I hope that I was able to give you a quick look at the workflow with Flutter. And now we will switch to the presentation. So let me work. Okay. So we've talked about what is Flutter. We've seen how it works. Now let's talk about why would you like to use it for your next mobile project. First, let me tell you why Flutter could be a better choice than other approaches to mobile development. When thinking about creating mobile applications, the first thing that comes to mind is to write it using native platform languages like Java, Kotlin, or Swift, Objective-C. This solution is ideal in terms of performance and native feeling, but requires additional resources and can lead to differences between the two versions of the applications for each system. The other solution is to use frameworks such as Flutter or React Native, which allows simultaneous development for both iOS and Android using the same code base. This approach greatly reduces development time and required resources. Many front-end engineers could gravitate towards React Native because of similarities with React and usage of JavaScript. But Flutter, even with the need to learn Dart, could be a better choice when you start from scratch and target mainly mobile devices. It offers better performance because it compiles to native machine code, as Ludwik mentioned, precise control over rendered pixels thanks to custom engine, and easier access to native platform features. While Flutter may be harder to learn at first than React Native, it shouldn't be difficult because it follows the same principles as React. Both use reactive architecture, and developers familiar with TypeScript should be able to catch up with Dart really quickly. Moving on, let's talk about the rich ecosystem of packages and developer tools that Flutter provides. Flutter, along with Dart, have their own package manager called Pub. There you can select from around 42,000 packages, which span a wide range of functionalities, from UI components to state management solutions and integrations with various services in the form of SDKs. For example, we have Firebase integration there. Some of the packages are maintained by the Flutter team, but everyone from the community can contribute and publish their own. The site helps developers in finding well-written and maintained packages by providing a score, which takes into account things like following Flutter conventions, testability, etc. I also mentioned a variety of developer tools. During development, we have access to flutterdev tools, which allows inspection of the widget tree, debugging, network tracking, and profiling, and also look very similar to browsers developer tools. Flutter also provides language server integration in many popular IDEs, which you saw in action in the Visual Studio Code. This allows developers to use features such as easy refactoring of the widget tree and automatic code formatting. Of course, there are also third-party tools that come in handy during development. For example, CodeMagic, which is a service that simplifies the process of building Flutter applications in the CI/CD pipeline. I should also mention that many packages support code generation, which greatly improves developer experience by not having to write boring boilerplate code. And probably the most significant part of why would you choose Flutter would be feedback from our experience. First of all, I would like to talk about the previously mentioned ease of learning of Flutter. My role at deepsense.ai is front-end engineer, as I mentioned, so I mainly worked with web frameworks like React. When we decided to use Flutter for one of our projects, I needed to learn it along with mobile development best practices. It took me less than 2 weeks until I was ready to contribute to the application we were creating at the time. As you could see during the code demo, Flutter is very similar to web frameworks, and Dart has many similarities with JavaScript. That allowed me to transfer most of my knowledge from web development to mobile in almost no time. Second topic, where Flutter was really helpful, was design and ability to easily modify styles of the material widgets. During the development of the previously mentioned application, we had to incorporate our client's design system into the code. At first, it seemed as a very difficult task, requiring us to create many widgets from scratch. But Flutter theming helped us greatly. We were able to define a large part of the basic styling using application-wide theme and utilize a mechanism called theme extensions to provide color palette across all widgets in both light and dark mode. Then we just needed to create a little wrappers for existing material widgets that set the rest of the styles. One code base, multiple platforms is probably one of the most talked about features of Flutter, and we also benefited from it greatly. The mentioned project revolved around creating an Android application, but we also needed a way to easily test new features from our PCs without using emulators. Um, we were able to utilize Flutter's multi-platform capabilities by hosting a web version of the application, which imitated native experience without any special changes in the code. Ability to access the application through the browser greatly improved our testing pipeline and allowed the rest of the team to develop features faster with confidence and easily check the results in the app. So wrapping up, these were the points that can help you decide whether to use Flutter or not in your next project. Here we have a list of some useful links. Going from the top, widget catalog, which contains a list of every widget available in the Flutter out of the box. It can be used as a reference when developing. Packages catalog, mentioned before. Flutter course on Udemy by Maximilian Schwarzmüller, which we can recommend as a starting point when you want to learn Flutter. And last but not least, the Boring Flutter Development Show, which is a series created by the Flutter team, in which they built an Flutter application from scratch, showcasing their day-to-day workflow. And that would mark the end of our presentation. Thank you very much for listening.